So today we'll talk about what is a data lakehouse and what is Apache Iceberg. So for the last few years, we have been building cloud data warehouses. Cloud data warehouses, typically, simplest way to look at it, have two layers. One is the storage layer, and the other is a compute layer. So you load your data into the storage layer, and then you use the compute layer for your processing, whether you have BI workloads, whether you have machine learning, or you're trying to do ad hoc analysis. Once you load your data is logged into the cloud data warehouse, and you're forced to use the compute of the cloud data warehouse. So these cloud data warehouses are, think, for example, of Snowflake, Databricks, BigQuery. So let's contrast this now to the world of Lakehouse. So how it looks like is you have a storage layer, but the storage layer is in a form called open table format. So this makes up your storage layer, which is essentially file storage on top of object stores like S3, Azure Data Lake Storage, or Google Cloud Storage. Now, you also have another layer for compute layer, but in this, the compute layer is not bundled with your storage layer. So you have different type of, you can have multiple compute engines working on this data. So this compute engine, think of it, one engine could be Snowflake, one engine could be Databricks, another engine could be a Trino engine, Dremio, and others. So what a lakehouse allows you to do is separate your storage layer from the compute layer, unlocks it, and allows you to have a choice of compute, and eventually does is it reduces your overall cost. Now, one more click down into this layer. What is this made up of? So there are multiple components to this. So you have a set of, and there are three actually formats here which have been prominent over the last 3 years. There's Apache Hudi, Iceberg, and Delta format. Out of all of these, Iceberg has emerged as kind of the clear winner. So what does it look like, Iceberg, if I take it down to the next level? You have a set of data files at the lowest level. Then you have a set of metadata files. And these metadata files also are called, sometimes they have special types of file called manifest files. And then you have an Iceberg catalog. So the Iceberg catalog points to this metadata file, and this is where your table definitions are, and these files point to the data files. So any compute engine, when it needs to read or write, has to go to the catalog to get the pointer to the metadata files and the data files to write. So the combination of an Iceberg format and the Lakehouse architecture allows you to separate your storage and compute layers and be able to bring your choice of compute for the right type of workload into your environment, and ultimately giving you the flexibility and reducing the cost.